Dude, OBS's text is so bad. I need to make a third-party text plugin. Why can't I change the color back? Oh. Okay. How do I make a rectangle? Stop snapping. Do not. How do I tell OBS not to snap? Because otherwise it's impossible to put anything anywhere. Also, how do I drag more than one item simultaneously? Oh my God. Look at all the effort I go through to put on a high production value, high quality stream for the people. How's it going, everybody? I can't move the text. It's not responding. We've got to fuel up with the carbs so we can blast ahead. I tell you guys, I did this morning stream and then I worked a lot off stream and I just did an incredible amount of stuff. It's like I did at least 3 days worth of work in 6 hours. It was crazy. That work was mostly about restructuring things and changing some representations of how things work. But I believe that that has now set us up to make some new gains. I'm going to cook up a little bit of protein so it's not only carbs, and then we'll get started. Anyone have questions? Do we have a Blender Maya exporter that exports models? Yes. We actually export models as text, but it's not a super inefficient text format like Collada. It's just... Actually, no, our mesh format might be binary. Let me see. Like, I don't know. So triangle list mesh. This is a format I did a long time ago, probably for Happy Cake. Okay, that one's, but the meshes are binary, yeah. I forget. Like, it's been a while. What's a good Weissman score? As low as possible. Here's what we're going to make. We're going to have pepperoni and eggs with melted cheese on top and then green chili salsa. And that is going to help us make the gains. Pepperoni's got to bake. Questions? Questions? If you at me with the questions. Would a final score of 395,140 be bad? Yes. I mean, it wouldn't be good. A final score of 500,000 would be really bad. Is it a cooking off-screen channel now? When is it not a cooking off-screen channel? I mean, come on, guys. You know the deal. How hard will it be to reach the same possible level of code optimization with the custom x64 backend? I don't know. I suspect not actually as hard as people think. But I don't know. And that's, you know, part of the reason I don't know is because that's not really what we're trying to do yet. And part of it, like, so part of the crazy stuff that LLVM has to do has to do with the fact that C and C++ have kind of crazy language semantics that invoke certain problems, and that the designers of the language semantics do not seem to care very much about solving those problems. So what I would like to do is observe how optimization goes and then introduce language semantics that provide better optimization. So our calling convention is already one of those. Like, our calling convention reduces aliasing tremendously compared to C++, right? So we don't have to do as much like alias analysis because by definition, certain things don't alias. So like things like that, I think people would be really surprised how far they go. But the problem is it's very hard to compare apples to apples because like a program idiomatically written this way in this language would not look that much like a program written idiomatically in C++. And then if you were to try to A/B them, how do you know it's a fair comparison and whatever, right? And if you use a common benchmark, like that's kind of unfair because compiler people spend all day making the numbers lower on common benchmarks, which is different from them actually being fast on generally useful programs. So you're sort of competing against like an unfair terrain if you haven't spent years optimizing that benchmark. Like it's, I don't know. Yeah, I'm just not going to, we'll see. We'll see when we get there. Gains is a metaphor? No, gains is real. Gains is real. But I will say further on, let me flip the pepperoni, and then I have one more comment about the LLVM question. So what you didn't exactly say this, but that kind of a question is illustrative of a kind of limiting assumption that basically holds back most of the smart people in software, all right? And that assumption is, oh my God, it's so much work to do anything big or significant or important, I just can't do it. And nobody could do it, right? Except maybe Tim Apple, right? And that's not true. And if you believe that it's true, you'll keep yourself from doing useful or important things. Yeah, it's really, these things aren't as hard as you think, in part because many big projects out there are done badly, so it's not hard to do things better than them, in part because many big projects are defocused and are not really trying to solve the problem that you're trying to solve, in part because knowledge moves on over time, in part because as projects get big, they become more cumbersome. They have this disintegration of coordination that happens as complexity rises. And they have this disintegration of, again, of focus where it's like, wow, this big project is clearly took them a ton of work to build it, but I only want 1% of that project, right? All these things happen. Who in the software industry do I consider to be doing good things? Very few people is the answer to that right now. Pepperoni is done. The eggs are cooking. As soon as I flip the eggs, I'll put the cheese on them to melt. And of course, I forgot to top with sesame seeds and sea salt. It's going to be so good. What would I consider to be good? Would I tell new grad software engineers about how to do good work? I mean, I talk about this stuff all the time in videos and lectures, so I don't understand the question. Like, do you not have a picture of what's good? Or do you think that mine is tremendously different? What I find is that actually a lot of the time people know what's good. They're just afraid to have standards. Something like that. Like most people are afraid to have standards because they feel they themselves will fall below the standards. And so they say something like, it's not reasonable to have standards or something. I don't know. Like I don't understand people's psychology, but something like that is happening. It's actually, that's the biggest difference between when I was growing up and when kids are growing up now who like computers. When I was growing up, smart people who liked computers had agency, like they had the power to do cool things. Now that's not true exactly. Like people who like computers have agency to go get a job from Tim Apple or have agency to go do Silicon Valley business stuff. But like, or to be a small cog in a large open source project that they won't admit is mediocre, but like people don't really believe that they have agency to do strong, powerful work anymore. And that's a problem. Like that's a sign that the environment is kind of diseased and we need to clean it up. Like we need to fix it. What do I make of fast inverse square root these days? It almost never matters. Like, just make your program divide by the square root, and then if you see that on the profile, think about fast inverse square root. All right, we're almost there. The cheese is melting. Oh my goodness, guys, check it out. So we've got eggs on pepperoni with green chili sauce and gomasio and melted cheese and extra salt. I don't know. Let me try to tilt that toward the camera as much as I can without it falling. Oh God, it's falling. Anyway, you see the deal. How do you start cutting the disease? Start in the education sector or, well, I would encourage people to pursue alternative education sectors. That would be one way. Another one is just making examples of things that work. Like people don't remember what it means for stuff to work anymore. Even physical devices. Like people are too dumb to design physical devices that have knobs and buttons on them anymore. So all of our physical devices don't even work and are hard to operate. It's like, are you kidding me? That's where we're at? And then the software on them certainly doesn't do anything useful. Green chili salsa is really good. A coworker of yours expresses something similar to what I've said, except it's more that he distrusts his own opinion. because he feels uncomfortable placing himself in a position where he's criticizing other people, especially when those people are the types that are considered very smart by HN folks. Well, maybe he just doesn't have enough confidence in his opinion. I don't know. I don't know. I don't know what to say about that. I don't know enough context. The thing that I keep coming back to about that is that, again, people who've been on this channel a lot have heard me say this a few times, but like engineering is about judgment. You have to judge whether the solution is good or bad in order to be a good engineer. Now, either you can be private in your judgment or you can be public in your judgment. But what you can't do is not have judgment, or else you're kind of mediocre at best. That's just fundamental to engineering, because you're trying to solve problems that are hard in the way that is best. You can't find the way that is best without judgment. So like, if you have judgments, but you're being very private about them, I mean, there are ways to do that, but a lot of people do that in ways that I regard as kind of negative as well. Your pet peeve in the web is no one remembers that a website is just a web server, which is just a program that listens on port 80 and responds to TCP requests. Yeah, nobody knows that. Nobody has any idea about that. We're going to start making gains here soon, but I want to eat a little bit of this food while it is warm. No customer wants the simple web page that renders text on port 80. I'm just going to time people out who say customer doesn't want. I'm sorry, nothing personal, but I'm tired of the mediocrity. I can't handle it anymore. That is the problem. The problem is that the people who have the ability to do otherwise choose not to do better with excuses like that. Let me ask you this. Is Elon Musk saying, no customer wants us to build a Mars rocket, so we're not going to? Is Elon Musk, did he say, you know, customers don't really want electric cars. They just want cheaper four doors. And there's no infrastructure anyway. That would be hard. So, and starting a car company, there's already enough car companies. Customers don't want more kinds of cars. Come on, guys. The reason that customer line bothers me is I read it all the time on Hacker News. And it's one of those memes that keeps people in the zone of mediocre results. And so I have to treat it as hostile because it's a meme that attacks smart people and gets them to stay within a range where they won't have world-class results. So it's a hostile, like ideas like that are hostile memes. You have to understand that. And they work because they're effective at getting people to believe them. Like things like that, statements like that, they sound reasonable at first, which is why they propagate. But they're hostile. You got to realize they're hostile. Didn't people once say, why would anyone need a personal computer? Yeah, the guys deciding business strategy at IBM thought that. Oops. Unisys also, I think. All right. That food is delicious. But it's time to lower the Wiseman score. We've been waiting long enough for the gains. In UI test terms, you think it is good that less than 50 tests run in half an hour? No, of course not. That's awful. How do you do anything in that circumstance? I mean, number of tests doesn't exactly matter. What matters is how many tests do you need to run to know that your changes are correct? How long does that take? All right. I want to go to here. And I now have the ability to combine some of these instructions. So we're just going to try doing this. We're going to say, we're going to go if 2 and we're going to say cc less, I think. And this is for numeric for loops. We're changing the loop condition at the end. We can actually write a simple small program to test this at the end. So we're just saying, if index register is less than write register, we go to somewhere here, the -1, that we will fill in. Actually, is that right? Yeah, I guess so. I mean, this seems weird, but okay, so we don't need condition register. Oh, this is the one at the beginning where we skip the beginning of the for loop. Yeah. Okay, that's why it seems weird. So if index register is already out of the range, and actually we could do this. Let's see what happens there. Oh, let's make debug compiler because that is what outputs our Weissman score. All right. So we were at 395.140 and now we're at crash. That's great. Oh, duh. It's this. $394,502. What is that? I need. All right. Well, that's 640 gains already. I mean, you can't even ask for more gains than that. Actually, you can. Okay, let's run the tests. Well, let's delete a bunch of this stuff. We're just going to do some numeric for loops. Just to double check. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And then we're going to do some 9 to 5s out of homage to Dolly Parton, and they should not loop. Yep, great. Okay, great. Let's make some more gains. Okay. So we've got a similar thing for numeric for loops down here. Oh no, I don't know if we can do this. So this matters if the iterator is unsigned. All right. let's okay. If the index is signed, which it normally is going to be, we do some stuff. Otherwise, we do this. Oh my gosh, look at all this. What a mess. I think we should push the debug expression up here. Okay. Okay. And so we do something. Actually, I think we do this, and then we do something here. So if it's list expression right, that means there's a range. Otherwise, it means we're iterating over an array. Okay. So here we say we want to jump if the index register is related to the right register in some way. If it's downward, we say greater equal. Otherwise, less equal. Jump to okay. I don't know. You don't need to say jump because the debug output it'll be a jump. Okay, so actually, and then we say loop top basic block. So the problem with the unsigned version is it's kind of a mess because it is. All right. Maybe there's a better way to do it. Okay. All right. If we're going down and we're greater than or equal to endpoint, we continue. Otherwise, there. Okay. Now, if it's the array version, wait, what? What? That might be a gain. We're not going to worry about that yet. Okay, so for loops. It's kind of bothering me that the signed and unsigned are going to be that different, but oh yeah. Let's jump if to. I probably messed this up real bad. Greater qual. All right. Chances of this working, not high. Told you. Okay. Why not? Let's do this. All right. So let me just look at the code that we are generating. And we're just going to do this one. It's even going to be just a very empty thing. Okay, so we start constant 1. We copy that for some reason. Constant v4 is 5. We jump if v2 is greater than v4, which it isn't. This is our body of the loop, which doesn't do anything. And then we add 1 to v2. And we jump to 1 if v2 is equal to v4. That's not right. Oh. Duh, I hope someone caught that in chat. All right. Well, now we can't tell if it worked, but this looks better. Actually, though, yeah. This should be greater than or equal to. Is that messed up? CC greater equal. What? Line. Oh, no, this is the start of the loop one. Yes. So, right, V2 is the iterator, V4 is the endpoint, and if we're past the endpoint, go to there. Actually, though, if it's signed, we can get away with checking only at the beginning. Let's make it work, and then we'll continue. So let me go back to this program, and we'll re-enable this. That's exactly what it's supposed to do. Let's try the Sokoban game. 393744. That's worth updating the Weissman score, right? If it works. Let's run the tests. So we are now at 393744. Boom. There is a YouTube video you can watch to explain Weissman scores. But if I link it, I'll get banned off Twitch. Okay. Yeah. I guess we'll leave it with two branches. You could have like a jump back to the beginning of the loop, but it doesn't really reduce code in any way. Okay, so now we haven't tested this one, although I guess that's fine, or this one. So what's going on here? This looks vestigial to me. That looks like we're reevaluating the list expression every time. That's kind of crap. I think somebody might have filed a bug about that a while ago. What does that do for our Weissman score? $393,915. It makes it worse. Or maybe the same question mark? Why does that make it worse? Computers are a mystery. I simply don't understand what that is doing. Okay, so we uncommented that. And we're going to check our Weissman score again. No, it's just higher now. It's just, our computer decided to have a higher Weissman score. It's okay. It didn't. It just keeps going up. It's just settled on a higher Weissman score. Okay. Anyway, we got lucky with the 700. That's how I'm going to interpret that. That doesn't make sense to me. Okay, I kind of don't believe this is. Oh, yeah, okay. Let's. I like this form better. Let's just make it compact. And there. So much less code than this. And that's not enough to bother refactoring together at that point. Get rid of this. Okay, jump back to the top. Jump back to the top. So this is kind of the mess that we wish we could get rid of, but it only happens when you do an unsigned iteration, which again is rare. Okay. Okay, that might be the gains that we check in there. Like, that's pretty good. Pretty good. I think we move on to the next gain. We'll run some release bills tests just to. We have to re-raise our Weissman score because they're too high. So it's really like 393,969 or around there. Which is still great. We're still winning. All right, release build. Okay. That's very good. Very good. So we're going to check this in and we're going to look for more gains. Okay. Now, what's our... We have our other little mini benchmark, which is... I think we're probably still at 309 on the main. Yeah, 309. So we didn't have any loops in here. Okay. Let me look here. Oh, switch statements. Yes. So we have a similar case. We don't need this size. That's vestigial. Okay, I'm just going to paste this into both to start. Because this one... We make a string comparison. And then we jump if we're equal to 0, I guess, to the next case. But if it's non-strings, then we actually want to do an if2 condition register write register. All right. Condition register write register into case result register. I don't get this. This is weird. This looks... Why is this one jumping if equal to 0? That doesn't seem right to me. Oh, that's if this is false. Okay. On the other hand, here our jump if 2 is fine. Now, almost all switch statements are over integers in this language, so it should almost always be the one where we eliminated the instruction. We didn't need that. So we also removed a value number per case. We're not doing Weissman scores for the value numbers. Oh, okay. That wasn't good. Get full size string print. What? I messed something up. Let's warm up the debug builds. I mean, I can always go one step at a time. Oh, it's not equal here. All right. Three nine two eight one two. That's pretty good. Bought us another 1,000. We're making gains, everybody. Making gains. We'll run LVM tests again as well, just to be paranoid. Okay. Right. All right. I don't see anything else to do there. Although there might be something. So all right. Signed for loops have dropped back to for loops with signed iterators. Iteration scheme. Only unsigned iterators need the complexity involved in avoiding infinite loops due to wrapping. Yeah, we passed all the tests. This is good. I think we checked that in. Boom. Okay. That'll also make those easier to read. Next, I'm going to look for compare ones. These are emit cast to bool. That's not going to matter. I should look for jumps. Jump if one. This, we already did patch slot cleanup, or I did it off stream. This is just where we were already. Oh. Oh. Right. Okay, we might have to Wiseman score. We might have to lose some points. Actually, no, because we have it at the top. Dude, the things we do to be good. Okay. Okay. I don't understand, though. Hold on. Okay. I think there's a gains to be had there, but we have to fix this other thing, actually. Problem is I don't exactly... I don't understand why we're reassigning that. Let's just do this. No, you know what? We're going to be hardcore about it. So the reason I'm saying gains is because we can get a gain right there for every for loop 1 instruction. I am worried about you know what? Actually, okay. Here's what I think about this. that instruction was there in order to catch the case where you've got a dynamic array and you're calling some code, and that code like adds something to the array while you're iterating over it. And that changes the pointer. But I think we should just make that illegal because you probably didn't mean to do that. Maybe you did. But the thing is, the index declaration, okay, no, okay, this is, okay, never mind. That thing that we did delete was vestigial, actually. It's this part. Okay, I don't actually know the right answer as to whether I should delete this or not. We're going to leave it for now, but if we decide I don't know. Like I can envision the kind of loop where you're iterating over a thing and you keep adding to the thing. That's a useful thing to do computer-wise. It's just, I'm not sure if we want to pay performance for that everywhere, but maybe the optimizer can catch it in most cases. Or maybe we add a directive later that says, hey, we're modifying this during iteration. Something like that. And then we could have a compile time check if that directive isn't set that asserts if your array pointer changes. Okay. All right, we're still around 392,667. And I would update the score on the scoreboard, but I think we're about to make another gain. Which is this. I think emit, array, base, and count has been modified since this was written. Oh, no, it hasn't. So either you can pass it in -1s, or you can tell it what for. Now I need to know for sure that I always do that, which it does look like I, oh, this one was not initialized. Okay. Okay, so then that means this wouldn't be necessary. Okay. 392780. That's a little bit better. That's not as much better as I expected. What was it last time? 392. Wait, it got worse. What? Why did our Wiseman score get worse? $392,366. All right. It's got a little noise in it. It's got a little noise. Okay. I don't exactly know why that got worse, but let's run the tests. Are negative gains technically still gains? I mean, come on, bruh. Let's make a release build, and we'll run that on LLVM tests. Okay, what was our Wiseman score this time? 392,657. We're going to update that. 392. It's non-stop action on the stream tonight. Look at our gains. Did I fix the camera problem? Yes. That was fixed during the morning stream today. It was, what was the problem? It was an x64 register allocation issue. I've done so much since then. Oh my goodness. Okay. So we're going to try some release LLVM tests just to mix it up a little. And assuming that these pass, we will look for more gains. Making gains. Okay, what were those gains? Those gains were more for loop gains. We definitely could do some gains, like I said, involving not reloading the data pointer. All right. I had on my list to look for some funny jumps that didn't make sense in this readout. Oh, it might have been in a different function. Yeah, okay. So instead of dumping this one, I was dumping this one because I had a bug here off stream, and I was like, hey, what's the deal with this bug? So I fixed that. And then I noticed some things in the function that seemed weird. Like around line 893. I don't know if that's changed. But this function is pretty different in character from, like, the init is pretty linear and does a lot of things. And this has like more if statements and short circuits and who knows what, right? Okay. $893. Okay. Oh, it's that. Okay. So we're comparing the truth value of this. We're knotting it. Sheriff of Nottingham. And then we're jumping if that's equal to 0. So like this looks like a bunch of weird nonsense, but like this is the break statement. This is the this is the break statement. This is jumping over the break statement, right? Now, I think if an optimizer ran on this, it would do a few things immediately, right? And I actually don't think we want to do any of this right now, but I got excited at looking at how much of this we could do. So this is a jump to a jump, right? This is just like jump here, jump there. So obviously we could substitute this here. And then I think if you do that, nobody can ever get to this entire basic block. So that gets rid of that instruction, right? And then this jump 17 is a fall through all of a sudden, which then makes this basic block all the same basic block. Actually, I don't know if we would bother doing that. Probably not. But yeah. So at some point, like it's interesting where to draw the line of what do I try to clean up on the initial output and what do I try to clean up otherwise. Now that said, this kind of a situation where you have one block with just a jump in it, that might be a little bit of a common thing. I'm not sure. We'll see. What I feel like attacking is these knops right now. I don't remember why we thought we needed them. So let me go figure it out. I saw it earlier today and now I still don't remember. Might want to delay jump threading until you have a control flow graph, though, and only thread jumps to blocks with one incoming edge. I would have a control flow. I essentially have a control flow graph. I mean, that's what these basic blocks do. We're not quite recording all the data, but we basically have that. And yes, I was saying that we would do that if that was the only way to get to that thing. Okay, so these knops, I think this is just here. I mean, maybe this doesn't really count as gains if we remove it. No, we should remove it. So this is not a good comment. I wrote this comment and I said, if the scope close outputs no instructions, we don't need this knob. Okay. But what's it for, actually? It's something about debug info, but I didn't explain it well enough to myself, right? We're putting it before the scope close. I guess so that you have an instruction at the close brace before jumping up to defers, etc., which can be disorienting. Okay, that makes sense to me. Now, emit scope close. I'm going to do this. We're only going to put a NOP if we need one. Did I check in our gains? I don't think I did. Maybe I did. Whoops, not add patch. Scope close, emit scope close. By default, we don't request a NOP. So we're just adding all the defers. Okay. Right, we don't actually emit anything here. We just collect things that are ready to be emitted. I did check in. Okay. Good. Oh, that was release again. This won't have any effect in release. Oh, yeah, it will. That's release compiler versus release. Yes, it will. Okay, never mind. But let's do debug so we can get our Wiseman score. $390,703. Remember yesterday or whenever we were trying to get below 400,000? Now we're trying to get below 390,000. I'm going to put 391,228 as our new Wiseman score. If we pass the test, which we will, because that was pretty easy. So that's, 1,000 NOPs that we removed from the program or whatever. 1,400. Yeah, C++ is crazy about, it's really annoying. It inherits it from C, the declarations. Okay. That's great. I think I got all the compare combines. No, I didn't do this one. Oh, but this is unsigned. Yeah, I can't really do anything about that right now. All right. So now also I can look at, this will be the same with the jumps. It just won't have the NOP, which will make it look slightly better. Line 8, 93. Boom, boom, boom. It's still a little bit silly, right? Like this pattern actually is very recognizable now. It's like we're jumping here if some condition, or we're jumping there. Of course, you can negate the condition, right? You could say jump 16 if V90, or jump 17 if V96 not equal to 0, right? But this is a sort of thing that you probably want in the back-end optimizer, right? You don't really want to try too hard on this in the front end. Maybe, although if it's easy, if we find cases when it's easy, it might be worth it. It's just, I'm not convinced that this is worth adding the complexity. Although, I mean, here we're doing literally the same thing, right? What does that look like in the source? It's just breaks. Oh, because that's the end of an if statement. That's actually probably not that rare. I don't know. It might not be that, because if you have other statements after the break, you don't get this, right? Compare followed by not is also less than, oh yeah, totally. Like this is the other thing. Well, okay, this talks about one of the gains that I wanted to make. So obviously, again, in the back end, you want to have all kinds of logic, or in the optimizer, which we don't have one of yet. You want to have all kinds of logic like this, where if you have a compare followed by a not, you can fold them together if nobody else uses V95, right? Like if your reference count, I don't know if I'm going to have a reference count. I guess that's probably what people do. But if your number of references on V95 is 1, therefore it's only this not, and you can toggle the compare, right? And get rid of the not. However, this is in the source code as an if not whatever, and if nots are very common. Like I do them all the time. And so again, it's not in vogue to do this in your front end, but for things like this, I kind of want to fold it into the initial emit so that this comes out better. And I also want to fold in compares. I think that's going to give us the big gains. But first we'll do the knots because we happen to be looking at this. Choosing block ordering, which way to do conditional versus unconditional jumps is best delayed after register allocation so you know whether either jumps needs to do register shuffling. Yeah, I don't have a register allocation story yet. I haven't decided how to do it. I know it's not going to be graph coloring because that just looks really silly to me. Like graph coloring register allocation is computer scientists solving the wrong problem. But I don't have a story for what it's going to be. But yeah, maybe I take that advice and do register allocation first. Would it make sense to treat if not as its own construct? No, not really. Because any compare that could be here has a noddable version, a knotted version, right? So The if can just see that it has a not in front, right? So that's all I'm going to do. And in fact, we can do that on while as well. So when we emit an if, we're going to do the following. Let's just do this. Okay, so here we do post not condition, right? And then if notted, we say not equal. All right, this is going to get hairier in a little bit because we're also going to bring the compare in here, which again is not in vogue in compiler front ends to do that, I don't think, but it just results in tremendously better debug build code, so I'm in favor of it. Okay. So we're going to do this count nots. Count and strip knots. So this substitution is just, I have to check this all the time. It's really annoying. It's a thing that I want to re-architect about the compiler, but like if, for example, you could have a not expression here, but maybe it was a user level operator overloaded not, right? That desugared into a procedure call or whatever. So you would figure that out here, right? You would see the substitution. Okay. If expression arrow type is not equal to not equal to what? Oh, it's unary, by the way. Not binary. All right. Count and strip knots. Okay. I don't remember how many we had. So we have 422 instructions now. We had 426. So we did strip some knots. This was around line 893 again. 893. Hey, look. Ta-da. So we got rid of the not. Now, we haven't folded the compare into the jump, which we could do and we'll probably do next. And then we could apply all this same logic to while loops. I need to figure out how to do that. Would this work with complex expressions like not loading and not running? No, not okay. So short circuit and is a weird one. That's actually that's actually one we could optimize. Okay. So short circuit and right now generates complex expressions, right? With jumps and stuff, because you need to not evaluate the second thing. But we can tell if the second thing is obviously trivial. And in that case, we can just do a regular Boolean and, you know what I mean? So that might be a good way to get gains, honestly. Okay. Anyway. What's our Weissman score? 388769, guys. Are you serious? That is such a good Weissman score. Remember when I was talking about getting below 390? All right, let's make sure the game runs before I get too excited. Okay. This is good. Probably doing these simple optimizations up ahead prevents the later optimization phase from being slow. I think so. Like a lot of optimization processes are searches, and so they're n log n at best, but sometimes a little worse than that. And also, just if you're going to do copious, like things like copious inlining, which LLVM loves to do, right? Clang and stuff, they just inline everything all the time. If the thing you're inlining is smaller, then that's faster, you know? So, yeah. Although I guess you can like try to optimize the inlined thing before you inline it. I guess you would do that either way, so who knows? Okay. But then maybe you don't have to do that. Maybe if it's already kind of reasonable, you don't really have to do that. And then you relax that constraint of ordering in which you can process things, and that's better for parallelism? I don't know. I don't know. Is there an obvious reason the builds are not deterministic? Kind of ish. So like our meta program is a user level program that is doing things asynchronously and may not be doing them in the same order all the time. That said, we probably should make that happen, even if it's like an option to run a little bit slower, because that way we know that there aren't bugs in the compiler causing different output, right? But this is a very complex compilation process that we're doing, and like it's controlled by a user level program that's like in a different thread from the compiler and like all this stuff. So, all right. Weissman score update. This is better gains than I was even expecting, guys. I was like, maybe we'll get down to 390 by the end of the night when I'm super dog tired. But no, we're doing better than that. We're going middle out on this one. I mean, we're 2% since the start of the stream. Or a little bit of the first gain was before the start of the stream, but... %. I don't think that's correct, but okay. Isn't the different total bytecode kind of a code smell? I don't like the phrase code smell. That's a red flag to me when people say that. So watch that. B, I mean, do you understand parallelism? I mean, that said, as I just got done saying, yes, it could be indicative of a problem, but we don't know that because parallelism. Yeah, the dump probably adds... Well, also we're running debug build compiler, by the way. But even with release with the dump, it takes, you know, an extra 0.05 seconds, let's say, to do this dump. That's actually faster than I thought the Windows console was. But maybe the Windows console output is like chugging out in parallel with the build happening or something. Okay. So again, if we go back to line 893, I get to decide... Oh, this doesn't have the line numbers. Release doesn't have the line numbers, which is something I want to do. I want to put that debug information in because I think beta testers will be interested in it. For now, we didn't put that because it's extra storage, but it probably shouldn't be that much extra storage. Like, I can probably figure out a way to make this debug info be the same as what we put into the PDB or whatever. All right, 893. Yeah, code smell, the phrase code smell I associate with Hacker News people, right? So I don't know where that phrase comes from, but that's sort of where I saw it being used. And I'm just like, ugh, I don't like it. Okay. So we have a compare of V92 is V72 not equal to 0. And then we're doing a jump with a condition as well. That condition could just be in the jump, right? And for general jumps that happen to be next to conditions, that's a thing that the optimizer should probably do. But if we're generating the condition as in we have an if statement with the condition, then it should just be in there. And wait, this first part should be easy. Okay. So the condition register so we say emit expression, and then I'm doing jump if. Is this really an if statement? I think it is, isn't it? 893, yeah. So like why? Oh, because it's a cast to bool. Okay. There's a cast to bool happening because operator not wants a cast to bool. This routine is being called inside if or while, which prefer to work directly with truth values. So if we see a cast to bool, strip it. Oh. Yeah. I think this works. All right, it's got to be a cast to bool. Okay. So just expression. I'm a little inconsistent with naming sometimes. Okay. So let's debug. So we had in this routine 422. Now will we get less? No, because I destroyed everything in the universe. Interesting. Interesting. Why would this break something? Yeah, I might want to remove empty basic blocks in trivial cases in the front end. Like, literally, it just happens sometimes that you go to say add new basic block and the previous one is empty. And in that case, I might just do that. But yes, in the back end, assuming you're trying to remove instructions, you're going to end up with empty basic blocks. And you probably want to remove them because that'll help your analysis, I guess. Although technically you don't need to remove them if your analysis handles it, because like they don't have an impact on target performance really. Like a basic block doesn't mean anything in terms of machine code. Okay. I'm a little curious. Maybe I can run this on the tests and maybe one of them will break, or maybe all of them will break. Interesting. So it has to do with a string, probably. Which is what I was thinking about. Like string to bool cast. Oh. Right. So we have this lax coerce to bool. You know what? Okay, here's what we're going to do. For now, we're going to say oh. Okay, yeah. So we were killing like the thing that actually figures out the truth value of a string, for example. However, I do think this is going to be not too bad for our Weisman score. And then we can build upon it for the future. How common are crank sessions? I've only done one so far. Actually, I did one today, but it was private. It was just me. All right. What's our Weissman score? 385, 336. Does it blend? That was huge, guys. We went from 388 to 385. That's the biggest single delta in Weissman score. Let's see if that's too good to be true or if it replicates. I mean, let's put 385 900 because that's closer to what we're getting, but okay, so that's more like 1,000 drop. We are 11,000 Weissmans down from the start of the stream, guys. That's insane. Okay, God damn it, you guys. I am tired of this. Hold on. Okay, so now what? I'm sorry, but so many people comment on that, and it's got this air of snootiness to it. It's like, do you not think that I'm working very hard to make the absolute best program possible? And can you not think of any reason why a high performance system would have different results from run to run? Like, come on. Come on. Okay. I've lost my sense of humor on this matter. I will start banning people. Okay. So, because it's breaking my train of thought. Like, it's so obnoxious. It's like we're doing such good stuff here and people are like, but. All right. So I'll be a little bit less rude. Okay. So that's pretty good. Let's look at what, well, I mean, maybe we run some LLVM tests real fast and then check in that Weissman score. 893. Hey, it's down to 2 instructions. Boom, boom, boom. So all our if statements, or a lot of them, are probably better. Better. Because we go to the truth value directly. So if you didn't put a not, it wouldn't have done the force cast to bool. So we're just, yeah. Great. Now we could do that on while loop as well. But I think we check in first. Oh, let's run LLVM tests. Let's do it in release because the LLVM tests are so slow. Oh, wait, we just did do release. Hold on. Oh, yeah, okay. Okay. All right. Whoops, I didn't mean to update. Well, there's nothing to update because I updated. All right. Strip. Okay. Okay, let's try that on while loops. I probably don't use while loops as much, but so because this is C++, of course, we need to move this lexically because let's make sure I didn't screw that up. Okay, so we count and strip knots. Count and strip knots. And it's the same thing. Like that. Well, that's a much less of a Weissman gain. In fact, hardly noticeable if it goes up like it seems to do all the time. Yeah. So that one, you know, probably doesn't apply in our coding style here. Hardly at all. We're getting some that are a little lower. All right. We're not going to bother updating the score for that. But we might for the next part. Oh, you know what I want to know? So our Sokoban game, when compiled with the x64 backend, such as this, let's make sure that's up to date. You know, like a week ago or whenever, it was 18 megabytes. And we did update it, but I don't think it changed very much in size. So let's see how big it is. 15.6. It was like 15.9 a couple days ago. 15.95. It was very close to 16 a couple days ago. Compiler is still less than 55,000 lines, although we're creeping up there. Game is nearing 100,000. Okay. So, we have so many other good games, good gains on this piece of paper. And it's only 10 p.m. Only 10 p.m. All right. So we passed the tests. Yeah. Okay. Next. Let's put that in the change log. Do their best to generate relatively terse conditional branches. Actually, I mean, that's sort of what this already says. It's just we're doing more and more in that direction. It's fine. Is fine. Only 7 a.m. with no sleep. Well, sorry for you. Sorry for you. I'm so sorry for you. Okay. Are the scores binary size? The scores are number of byte code instructions. So what happens is I run this, and this is just a spew of some random function that we're working on, and then this is our current score for the Sokoban game, by the way. So it's, 150,000 lines of code, depending on how you count, and it's less than 4 instructions per line, which is better than it was. Okay. Let's look at this if statement situation. Going back to, actually, that's not the best place. Let's see if there's somewhere in this function that has an appropriate if statement. I wonder what it does for this. Probably it generates a double compare. Right? Let's see, line 928. Because it's gonna evaluate the compare as a binary operator, and then it's gonna evaluate the truth value for the if statement, right? That's what I think. 928. So this is evaluating program mode global variable. It's dereferencing that. It's loading that into a value, right? And then we're comparing against constant 0. So like that's fun. That's an extra instruction that we don't need, and an extra value number. So yeah, so we're generating this truth value and this. So really all 3 of these instructions could actually be one instruction. It could just say jump 41 if v 120 is equal to 0. I also program the Sokoban game, but we have other people on the team who do that too, yes. Miss Strand is doing a lot of good explaining for people in the chat. Educational. All right. So like there's two separate things. So this compare could be optimized by itself, because that's not good that we're generating this. But also, this part wouldn't see that, right? So what we really want to do is, yeah, let's try that. Okay. So after we do the strip thing, after we get the strip stake, count and strip knots. Oh, 20201, that's what you were talking about. Bro, okay. Count and strip knots. We're going to do this just on the if statement right now. Okay. So now we're going to maybe go maybe split condition. Okay. If we split, else we do this stuff. Didn't need that. Okay. Okay. And then we go split left, split right. Jump if 2, 2. 2. Okay. Maybe split condition is going to start simple. And then we're going to make it more powerful. Okay. I mean, we could just go for it. Let's just test bed. Test bed. What is it called? Is equal. If that's not equal to token is equal, return false. We just want to address this one case so far, and then we'll generalize. Okay, we're going to say CC is get condition code from token operator type. Okay. If knotted, CC is okay. So we need to knot condition codes. I mean, can I arrange them so that it's 1 bit op? It's probably what x64 does, right? So equal and not equal, less and greater equal, less equal and greater, or greater and less equal, right? So greater is the not of less equal. Greater equal is the not of less. Not equal is the not of equal, right? Okay. Split left. Okay. So we're not actually looking for big gains yet, because again, we discounted most conditions. I just want to make sure that it works for this place. Where were we, by the way? I should write it down. We're at, oh no. It was something where something was equal to 0. Oh, that's the wrong function. I think it was here. It was program mode. Is it line 909? I don't know. Does anyone remember? I feel like it was earlier than 909, but okay. Program mode. Here we're sure doing a lot of stuff with that. Line 909. Oh, yeah. We've got... This is all made complicated by the ands, which, as we said, are not optimized. We had a simpler one, but it was equal to game. Oh, it's down this one, 928. 909 is just more hard mode. 928. So V121 is 120 is equal to 122. So we're loading program mode. Is it okay? That totally didn't work. Anyone have a theory as to why? Let's find out. So line 928. Nope, wrong key. Wrong key. Is it worthwhile to do a pass at just folding constant-based bytecode first? Well, I've explained this before in the stream, but we're trying to produce high-quality output before we run optimization passes. Because, for example... Wait, what? What am I running this on? Because, for example, you might just be running a debug build... Oh. That didn't work either. Oh. Wait, I really screwed it up. Let's just see. Let's put a breakpoint. Let's see what happens when I split a condition. So oh God, there's a control N in the file, control M. All right. I don't know how those get there to this day. It's been happening for years. I don't know whether it's Visual Studio that puts them in. I don't know if it's Emacs that puts them in. They can both go jump off a cliff for all I care. Okay. Like, why are you editing my file, by the way, guys? Has the size of Sokoban executable gone down? Yes, we just looked at it. It is significantly smaller. Okay, so what's the condition code? It's equal, right? Because binary operator, that's fine. What about knotted? False, okay. This is, you know, this is my suspicion for the most wrong thing, but we'll check this. Anyway, left return, right return. Okay. I mean, this looks reasonable. Oh. This has to be knotted. Actually. Because we're skipping around the then block. That didn't matter. Dang it, bro. Okay, hold on. This is a terrible name. What does go to source if part BC mean? Like, oh, it's the source of the go to. Let's just rename this. Let's call it jump if condition is false. Right? So if there's an else block, we go to the else block. Otherwise, we go to the, yes, okay. So we have jump if false, BC. BC just being, it's a bytecode instruction. So, yeah, this should be not CC. Okay. I don't know why that worked and saying not knotted didn't work. That's, my brain isn't seeing why. But hey, look, we got gains even from that little thing. We got gains. Boy. Do we do SSA in the optimizer? We don't have an optimizer yet. I don't count what we're doing right now as optimization exactly. It's like non-pessimization. We may or may not do SSA when I do the optimizer. The jury's out on that. I find SSA distasteful the way it is discussed in college classes and on the internet, but I've been thinking about what it means like for this compiler, like conceptually, and I have an understanding of it now that is like more simple than what everybody does. And so what I think I'm going to do, like a lot of the stuff that you use to compute SSA form, you kind of need anyway for modern optimization, regardless of whether you use SSA or not. So I'm just going to start building that kind of stuff. And I feel like the same way that we're doing non-pessimization here, I feel like most of the time you can do most of the SSA translations locally. Like, if you ignore the silly concept of phi function and like write what actually needs to happen down just directly, it's actually pretty obvious what to do when you generate code, how to generate it that way. So we'll see. We'll see. But then when you do that, it becomes obvious that sort of what you're doing is adding extra register or extra value copies, right? And so the theory is, of course, that SSA will help you eliminate things better than non-SSA, but you are emitting copies that weren't there. So there's that. All right. Let's naively, this would generate two compares, one for the x is equal to 5 and one for the one for the jump on the if statement. Maybe split condition lets us fold the Boolean op into the jump on the if. Yes, this is something that optimizers would normally do, but our working hypothesis here is that it's a good idea to do some of these things when initially generating code. Control M problem might be this line ending issue. What are these M's that keep showing up in my files? Yeah, sounds like my problem. In git config, I don't run git anything. No, that's not the problem. It's an Emacs bug. It's not the problem. Like, because these files aren't generated by anything. This is just source code that I'm editing, and sometimes control M's show up in it. Why? I don't know. I don't know. Not even in places that I'm editing. They're just like random places in the files. Okay. So that was me writing a comment. So now, here's what I want to do. Get get binop from token. I can ignore assignment return, right? Yes. Null and ampersand instruction type. Okay, so if instruction type is not equal to compare to return false. So compare to is returned by all of these. Is equal, not equal, less equals, greater equal. Sound familiar? Yes. So then we're going to say get condition code from token. And then we do these things. And maybe that'll work and give us more gains. Maybe it'll destroy the universe. It destroyed the universe. Wait, get bin op from token. Failed with exit code 000000042. Wait, really? What? Obviously, I should have looked at the code more carefully. If it's operator, only allowed to ask if this is an assignment. Like squeeze me? That's no longer true. Fine. Sometimes assertions cease their usefulness. Okay. Interesting. String comparison with equal. Oh yeah. Again, we can't do that. So oops, I'm going to put that as well. Where was the other one? Count and strip knots. Okay. No, not CC. There we go. Oh no, it broke. Oh, it breaks during running, not compiling. Oh, not It's weird. Wait, but that didn't happen. These are equalses. But this wasn't failing here. So what's the deal? What? Oh, guys. Okay, first of all, the reason why it didn't work to put knotted here is that I knot it before. I hope somebody caught that. Oh, holy God. I don't think that's going to fix this because this doesn't look knotted to me, but yeah. I'm just going to debug that because I don't understand. And we're going to line 127. Like VTune decades ago had this thing where it automatically tells you if your path is correct or not while you type it. Nobody else does that. It's so good. All right. We get the bin. What? There's a control M in the file. Look, it's in the middle of plug or allocate. We haven't even been editing that. Why is there a control M here all of a sudden? Because whoever is in charge of GNU doesn't care about anything, apparently. All right. Okay, so binary. Get bin op from token. Instruction type. Dummy bin op. Oh, this might be the wrong file name. Yeah. String to float. Oh, really? What? How is that not on line 127, guys? Oh, right. That's not the problem. The problem is whatever generates this value. This is not an if statement, guys. I don't know if you notice this. There's no if on this line. And assert actually isn't a macro here. Okay. What generates C? C is map B for stringify. There's no if statements in map. All right. Okay, so that was me just being confused for a little bit. Oh, maybe that's why the exit code was so long, because we were... Oh, because we messed up print. We messed up print. What about write number 1? Can I do that? 42. That works. That doesn't work. Okay, that gives us something very good to debug. Integer, print integer. Print U64 base n. So we start at the end. And we go backwards. Oh. Yeah, guys, remember how I said these things have to short circuit? Wait. Okay, this is confusing me. So that's not an if statement. I think it's probably this. Let's just say digits equals 5. All numbers printed shall henceforth be 5 digits. Okay. So that does fix the problem. So it's this if statement. If digits is greater than max output length, how hard is that? Well, let's look at it. Line 173, we have the new place to go. Conditions, line 173, close, go. Bam. Right, because it's not, this isn't anything funny. We get the condition code. Greater, right? If digits greater than max output length, is it knotted? No. I mean, this looks approximately right. Right? Digits. Split right, that's going to be max output length. Max output length. So these are the right things. Oh, except you know what? No, that's fine. So this is the thing that jumps around the true branch. So we do want to negate the condition code. You know what? Let's dump it. So we want to look at line 173. Okay. 173. Okay. If V9 is less than or equal to V17, we jump to basic block 1. That's a problem. Wait, that's the wrong, because that's just not jumping around anything. What? What? Let's call this okay. So why, this is really weird because it's like let me look at this again. Let me try to, it's an assignment. So here's the if digits is equal to 0 return. We say if V19 is not equal to V20, don't return, right? Did you knot it twice now that I fixed that internal knot? No, that's not what I'm seeing here. So jump to basic block 1 if V19, which is this read from probably format. V3 is going to be format. That's it's parameter 3. Format. Right? So we're reading format dot dot minimum digits. So that's the value. If V19 is less than or equal to 17, don't assign. Now the problem is I guess V19 is the register for digits. Okay, actually this makes sense. This looks fine. V17, big constant. Wait. Why is this here? Are we still outputting this? Oh, no, it's a different 64. It's this one and not this one. Okay. Okay. So that's our assertion. After the assertion, so digits is stored in value 19. A comment would have helped that, but whatever. If V19 is, I mean, this looks fine. The question is just, maybe the problem is with the jump instruction. So whereas I implemented jump instructions with these conditions and stuff, maybe they don't all work. Like what if I did this in LLVM and then ran it? Okay, then it fails the same way. So it's not that probably. Could be, but probably not. Am I being dumb here? Am I not seeing something? Line 173. Jump to basic block 1 if V19 is less than or equal to V17. Right? V19. So if V19 is greater than V17, which is OX40. V19 equals OX40. Okay. Now, let's look down here at what they use down. Maybe... So who uses digits? Here's a while loop. Line 181. Okay. V19 greater than V29. No, but we know that the value of digits works correctly down here because we set it to like 5 and it worked. Okay, wait. Maybe this is messed up. Oh, yes, I bet it is, guys. This is the implicit context demo. It probably messes with the context. And that is what broke. Default format int dot minimum digits, right? Oh. Or the signedness of the compare is simply not correct. Because this is going to be -1. Minus 0001. If the compare as performed by the jump is not signed, or as performed by the, yeah, let me check that. Let's make a tiny baby program. A is -1, B is 1. If A is greater than B, print A is greater than B, else print, All right. Okay, well, that's fine. That's what we wanted, I guess. Oh, we're dumping. I was like, why is that so long? It's because we're dumping the string thing as well. But here's our littler program. So we're also, it's a jump compare. Jump to V1 if... Jump to 1 if V1 is less than or equal to V2, which it is. I'm a little confused. I'm not going to lie. I bet this is something super simple, but we're late at night. The brain waves do not flow as readily. I did so much good work today, guys. If we can get this last gain nailed down, it'll be good. Like what? Let's just try that. So it's -1 every time. And that is fine. I'm using this right string stuff because that won't recursively invoke the print function that we are trying to deal with, right? So digits equals -1. These are much simpler routines that are used for like panic functions and stuff, so they don't have formatting and all that. So post like what? It's gotta just be knotted and my brain is not seeing it. Okay, what other explanations are there? A, the comparison is actually knotted and I'm off by 1. It didn't look like that. In fact, it didn't look like that here. B, the compare is incorrectly signed. But that wasn't true in our test program either, but maybe that has to do with the size of the value. No, because that's an integer. As well. If it's not one of those two, I don't exactly know. I mean, I could do exactly this same thing. Except I can make it -1. It doesn't go off there. What am I missing? Is this running during compile time execution some way? Can you check the equal since it seemed it was equal in the not toy version? No, I pasted it directly in. What am I doing? This should be so simple, guys. Should be so simple. You know what we could do? Could break out the big guns, guys. Actually, okay, let's run this during compile time. Make sure it breaks at compile time as well. Which function is it? Oh, so it was this thing. So when we do, yeah. So we're going to run array allocators as a no check-in. I just want to make sure that that fails. I didn't. So I think it's not failing during compile time execution. Wait, no, it's just not running. Why is that? Everything I know is a lie. Now I'm several things deep in computers are a lie and don't work. Although maybe it is. Maybe it's got another if statement problem in it that is activating differently. Okay, it is running. Oh, that's the wrong function, guys. I'm tired enough that I did the wrong function. It's map test. I was like, my whole life is a lie. Nothing works, but it does. It works. So it's working at compile time. That is important. Maybe it's failing the same way. In x64 and LLVM, because like I pasted those and modified them. There we go. There we go, baby. Now I need to think about what this means. So when I generate these condition codes in x64, okay, it has to do with the fact that the thing on this was not a bug in the code that we were writing with the if statement. That's why it was so confusing. This is a bug in stuff that I did earlier today off stream. And it's assuming that when we try to do an integer compare like this, that they're both the same sign. And in this case, I guess we're not casting them to be the same. Oh, shit. Guys. No, that shouldn't. I need to think about this. Does toSetCC assume anything about the condition code values? What do you mean? It has to be one of the known condition codes, of which there are only 5 or 6. Yeah, so there should be an implicit cast. But the thing on the right is actually a constant, which gets handled differently in a magical way. Assert is your friend, guys. Assert will save your bacon. I don't know why that would say not signed. So if I go back to the code, wait, where was it? Here. It's a constant, 64, which should be treated provisionally as signed. So I'm not sure why it's not. That's very confusing. Let's see what register sign does. It says get value type. Wait, which one was it? Index result, yeah. So this is, wait, 1153? What? 1153 is 0481, which means it's a 32-bit number? Am I wrong about that? $32-bit. Why is it 32-bit? Was there an implicit cast? Wait, no, it should be 32-bit if the thing on the left is 32-bit. So maybe it is, and I'm just confused. Hold on. Hold on. The other one, the right is BC index A. This is 3. All right, and the type is 441, which is 32-bit signed. Why is it? Am I minimum digits? Why is that 32-bit, guys? I have no idea what's going on right now. Does it have something to do with other uses of the constant? It shouldn't. It shouldn't. Early on, in the early days before I had decided on the language semantics and how things worked, that was a thing that could happen. And it made this weird action at a distance that was very unpleasant. So that's not supposed to happen now. Like, any use of that constant is supposed to be independent of any other. But honestly, at this point, who knows? I mean, I don't really see any. Oh shit, guys. I bet it's the constant sharing system screwing up, and we just didn't see that happen yet. Because some of the... Okay. This is like stuff from a couple days ago screwing up. Like, okay. This 64 is being shared. Now, the weird thing is... Okay, yeah. So that's why it's unsigned. We're going to have to give up some of our previous gains, but they were small gains. So the deal is we're sharing this constant. I don't know why it's 32-bit, but I assume that that's... Maybe the length of this string was 64. Because it's base 64 characters. Why would that be 32-bit? Maybe the code that constructs that. Yeah, the 64 is probably coming from here, guys. So let me just go and say that that was a failed experiment, but it didn't buy us very much anyway. We're going to go back to bytecode builder, but we're going to go to find or add emitted constant. And when we find an emitted constant, we're not going to size match it. We're going to say it.def, and it's got to be the same freaking type for now. Okay. Hey, look, it runs, everybody. The problem was not related to anything that we were That's why it was so confusing. I've learned to recognize that pattern now. In older days, I might have beat my head against the thing that I had just been working on for like days. But no, it was an interaction between that and other things that are not that new, but somewhat new. And because they're somewhat new, they haven't been tested as thoroughly. Yeah. Missing equals in those characters for B64. These are somewhat arbitrary. Why would equals be in there? There's 10, 26, which makes 36, another 26, which makes 62, 63, 64. Is there some standard that is different characters? All right, so now we have something failing, but, oh, well, hold on. The print, I totally sabotaged print. That could screw things up. Maybe not. Like, that looks like an actual legit fail, but let's see. Radix sort, line 138. I mean, a radix sort probably has lots of if statements in it. Yes. Maybe is sorted is wrong. This looks like it's 115, 29, 215. Oh, that's wrong. Okay, hold on. Because I changed the constant sharing, that is a relatively big change. So let's, in order to stabilize for a second, let's go back here and in the maybe split kind of stuff, let's put this thing back that was keeping us sane. And we'll see if that doesn't change anything, then maybe it's the constant sharing. Like the constant sharing could have exposed something else. Oh, our assertion on is signed is coming up with something else. Okay, hold on. So for now, we're just going to no check in on this and just return false all the time. We don't want this splitting stuff to interfere with anything. But this is probably something else. We get to go back and do invaders while this test runs. We've been down a little rabbit hole here. Ignoring this. Oh, wait, what? So it's the condition splitting actually screwed something up. Okay, that's weird. I don't understand why, because things should have implicit casts on them. In order to make them the same sign. That's supposed to be a thing. Let's see. There might be some assumption that I have not made, or that I have made incorrectly. So we're just going to rebuild invaders with this. Yes, it doesn't like that. Okay. Good to know. I'm getting tired, folks, but I want to bring this home. Since sound player. Line 546. Autocast, bro. That shouldn't. Shouldn't matter. Why would an autocast mess this up? Yes, we have OpenGL bindings. Why would an autocast? Because the type of that autocast is supposed to be fixed. Is there something about emitting a compare that does something different? Oh, maybe there is. What's it called now? So we're going to emit binary. And this is just a regular old integer. I get, oh wait, output channels max is a channel max, which is probably a frickin' integer. Okay. I could just see what happens when I step through and emit this code. It would not be an assignment. We would emit the left. We'd emit the right. And we would do the operator. Maybe AutoCast has been broken for a long time and we just didn't have an assert in the right place. Like, okay, so the thing about the thing about this autocast that I just put, or this assertion that I just put in, is it is in the jumps. There's very similar code for compares right here. Okay. And I guess we don't. Wait, what? Guys, this code is supposed to be different. Oh boy. Oh boy. That's a whole separate issue, but no. See this? This is assuming it's an integer operation, which is not good. Okay. But here, so we would be doing condition code 2 and well, let's just check this. Whoops. I bet that goes off. Even if we disable the maybe split. Where's invaders? I thought we have it in here. Oh, it's fine. Debug. Release build is old. Okay. Oh, that's me having edited the source code. Yeah. This was all ported from before enum support was super good. In fact, we had barely any enums. Okay, these were fine to do this. Okay, that was just me being me. Are there technical dev blogs for the witness? Well, there are on our website, which is down right now because I can't deal with how terrible the web is. Is signed is equal to x64 register signed. Yes. That's line 1820. Which one is that? Condition code 2, which is the compare. And that's in invaders. So this also is not a new problem. Here's what I'm going to do. I'm going to punt on this for a minute. And I'm going to put fix colon mismatch. Because we have multiple things I need to catch up on. This is wrong sometimes, but apparently our software still basically runs when it's wrong. Oh, whoops, I have to recompile that. Again, it's not that surprising. That's code I wrote this afternoon. It's new. It's not that sorted out. Did I do the website myself? Originally, I set it up, yeah. But then we had other people working on it and stuff. For this instance, what made me stop and think about other parts of the program? I don't know. I mean, I just was trying not to. So when things are very confusing, this is what I've learned about programming over time, right? Sometimes computers seem to make sense. Sometimes they don't seem to make sense. Sometimes you're looking at the situation and it's very confusing. And you're like, how is the computer even doing this? Okay. Usually in that situation, you're operating on a faulty assumption, and that faulty assumption is causing you not to see the problem, right? So I was like, what are my assumptions that could be faulty? Well, one of them was that the problem was really in the code that I was just working on. And, you know, you started seeing me guess about where else it could be. Oh, maybe it's an unsigned compare or something, which it actually ended up being, but for a different reason. But yeah, like these things. All right, so because I want to get this gain in, and then I want to amplify it up, and I'm getting tired, so my powers of brain are going to be running out. So here's the problem is we also need to, so the jump commands we're supposed to be using condition 1 and 2 there, but they aren't. I don't know why. I don't know if a file got accidentally reverted before I checked it in. I don't know if I didn't actually do, I swear I did that today though. So I'm going to write this down, mismatch 2. And this is going to say, so we're going to use this down here as well. And we're going to say, if it's a float operation, then we return. And that is going to be something we remove later, because we do want to be able to do these float operations. It's just those if statements will not do it. And that's fine right now, because actually the only time we use those predicated jumps is for loop iterations, which are integer operations. But we want to be able to you know, fold those together as a result of optimizations and stuff. So they need to handle float. All right. So we're going to reject if it's float, but we're not going to reject for either of these now. I'm going to see if we can do this for all our condition codes. Whoops. what? Oh, extra paren. How am I? I'm doing much better now that we found this thing. Invaders really doesn't like this. Wait, I thought we were punting on that. Oh, because I added it to the other one. I added it to both guys. Oh, you know what? In cases of operator double equals, I think we do. I think somewhere in the compiler for equals and not equals, we ignore sign flag. So this might actually be even intentional, but I don't want to figure it out right now. I'm going to defer it so we can nail some of these other things. Right, so we have one in here also. But that one probably won't live long because I want to, as soon as we get this nailed down, I want to refactor that to use the other thing, which is what it's supposed to use. And then it'll handle float in theory. Yeah, invaders passed because we commented out the thing that was killing it. It's been a little bit since we got some gains, but that's okay. That's okay. We've already got tremendous gains, more than I expected to get on this stream. We're hopefully going to get a little bit more, because since all these tests pass, well, maybe the game will pass now. Sure has been a while since we looked at our Weissman score. Look at that Weissman score, guys. That was worth an hour and a half of agony. Major victory, and we're not even doing it on float comparisons yet. Now, we do have some technical debt, as they call it on Hacker News, that we have to confront, but it's not that bad. The question is, does the game actually run? I'm updating the scoreboard. Holy cow, look at those gains. This should fix the 3 ops instead of 1 issue. Yes, in some cases, yes. Okay. That's good. We're also, we are not applying this to while loops yet, which this same splitting that we did for if statement, we could do for while. I'm just going to put that on the to-do list because I know in this code base, if statements are much more numerous than while loops. Okay, so let me check this in, and then we're gonna fix this part here, hopefully. Oh, hold on, I probably have no check-ins here. Yeah. Okay, so progress toward condition split for if statements. Okay. Okay. Yeah, I mean, you're right. We passed the 50K mark. That's serious. Like, we're way over 10% at this point. And there's so many gains. We're going to have to do another gains stream, guys, because there's so many left on this list that are going to be huge gains. Oh my gosh. Oh my gosh. Short circuit, and I'm not going to try to do that tonight, but eliding the short circuit, if you can tell that it's trivial, that's going to be huge gains. I won't say what these other ones are, but like they're major. So we're going to have to do another one. Early morning stream, it might happen. It might happen. Okay. Like, I've just been hyped to work on this. Like, this kind of work, like code gen of x64, I had kind of decided in my head was going to be a bummer for a long time. And then just a few days ago, I was like, you know what? No, it's time. The line must be drawn here, right? And I'm like, it's not optimized yet, but we have a lot of the infrastructure in place now for an optimizer. Not all of it, but a lot of it. And we're doing these non-pessimizing things, which are having a significant, like, in fact, one thing, whoops, let's remake the release build, because that was last built when it didn't work. This is just what happens when I hit F7 in my console. It runs the release build. Okay, so let's check our frame rate. It might be even higher now. Oh, it was promised one that had a relatively low frame rate. We're hitting 18 now. This was 14 before we started doing any of this a couple days ago. It was like, whatever, it was 60 something milliseconds and on the left-hand number. This is great. No, this is huge, guys. I'm digging it. I am so digging it. All right. And we have so many more gains. And again, all of these things that we are doing, these are not optimized build things. They take basically no time for the compiler to do. They do add complexity to the front end, but they take basically no time to execute. So you get this in a debug build, right? Which is great because your debug build runs better. It's easier to understand, all that stuff. Okay. So we did commit, right? Let me double check. Double checking. Boom. Okay. So now we're going to go over here and we need to deal with the fact that these guys are fully integer right now. That's not right. So we want to say mode equals condition code 1 of index result yeah. It's weird because the registers are different for reasons. Reasons that haven't paid off yet, but that maybe will, or maybe we'll change all this. Okay, so we do condition code 1 of and R left is load machine register. Yeah, just like this. Condition code 1. This is really old. I just never did this. Wow. Wow, says Owen Wilson. Wow. Okay, right? Otherwise, mode is condition code 2. And we load our left and rights. I did this on LLVM, right? Yeah, it's called make compare here, but register A, result, CC, next result are left. So condition code 2. So now this has the assertion in it now, or it will when we uncomment it, right? So oh, this is wrong. Oh, wait, I'm looking at the wrong one. Okay. So that should do the same thing, but also allow us to compare floats. And then I can take the restriction off our splitting. Wow. So we won't have more gains yet, because that wasn't a gains kind of a thing yet. We're just going to make sure all this passes. Is that level better than the LLVM FPS? No, the LLVM FPS is probably better because we actually do run a couple optimization passes on LLVM, even for the debug build. Because in part because that actually makes compilation faster. Like running the passes and getting rid of all the low-hanging fruit of redundant things in LLVM results in a better compilation time, or at least last time that Josh timed it, results in a better compilation time than just outputting. All right, so that's great. So let's try re-enabling this thing. And we'll see if we get any more gains. I don't expect much in the way of gains from this, but we might get a little. Well, we got 1,000 gains, or not quite 1,000. Does it run? It runs. Oh my goodness. Remember when we were just trying to get below 400,000? Remember that? Why would I sleep when I'm getting gains? Answer me that. On the board, on the scoreboard. Look at that. Look at our Weissman score, dude. Since the start of the stream, we've removed 16,000 instructions from the Sokoban game. Did we fix the camera bug? Yes. The problem was something in the simple little x64 register allocator. It was putting a modified version for a variable in a float register, but not killing the association with the integer register. So then somebody went along to use that variable and they used the old value in the integer register. So we just had to like kill that. How did anything else work? I have no idea. Sometimes computers are like that. Yeah. Okay. I'm just about ready to go to bed. But so tomorrow I want to debug that mismatch thing. I'm a little too tired to do it today, but I feel like it. I remember at least some intentional cases, and maybe we can exclude those from the assertion, or I don't know what. But maybe there's a legit bug there. So we need to take a look tomorrow. I'm circling that on my notepad as an important high priority item. Okay, I want to try the very last thing tonight is just let's do this maybe split condition for the while loop as well. All right. Do you still recompile polymorphic procedures for every call site and then deduplicate? No, we never did that. No. No, we do something smarter than that. Okay. So okay. Okay, count and strip knots. And then we're moving this because it's C++. So that's maybe split condition. And then down here, we're going to do this. So we do post not condition. Why am I saying 0 on bool? So silly. Okay. Post not condition. So we do the split. Wait, we don't need this size. Lol. Gains. All right. Okay. I think it's literally the same. Such that we might try to find a way to factor these things together. All right, jump if false BC. Well, that's different, the name. Let's call it jump if false BC. All right. Yeah, gains are not bug snacks. We did just have some bug snacks. That is true. We had about an hour and a half worth of bug snacks in the middle of the gains. Sometimes you just got to stop and bug snacks yourself a little bit. All right. Did we get gains out of that? Let's also make a release build. What was our last score? About the same. So, well, no real gains. Maybe a little bit. Nothing noticeable for this particular program. And that's not too surprising because we use for loops way more than we use while loops. I'm used to typing 2020. Almost 60 gains today. Well, some of those gains are like from the past day or two. But yeah, we've had a lot of gains. We've had a lot of gains, and we have a lot more to go. Many, many more. You know, this maybe split condition. I could just do all this in there and just return the instruction. And that would make me not worried about the complexity. You know what? Let's do it. Let's do it. Actually, all of this, guys. Okay, maybe split condition is going to go this is the helper. We're going to go maybe split condition. And what am I doing here? So all the rest of this is just gone, right? So we did this stuff. All right. And, oh, split left, split right. So we just want to call the helper on post not condition. Okay. So now our if is going to, it needs to call the helper actually for a minute till we factor it together. Blah, blah. Blah, blah. Blah, blah, blah. All right. Should not be any gains whatsoever. It's just a refactor. We're just making sure it works. Okay. So then I can call maybe split condition on this part. And all the rest of this goes away. That's gains. We're making some gains right here in code duplication. All right. How are we doing? 54939. We're going to end the night under 55,000 lines again. Thank you. Yeah, it's true that just because I don't use while loops doesn't mean other programmers won't. That is absolutely true. But it is also true that this language puts like a lot of machinery behind for loops and a lot of support for them and not that much for while. So you'd expect people to lean toward for loops because just a lot of stuff is built around them. All right. So again, no gains, just refactor. We're ending the night at 380 though. That's crazy, guys. That's so good. We're going to make a release build. Oh no, guys. We just weren't testing what we did because it was the other compiler. Hopefully it's fine. That was a pretty safe feeling refactor to me. Now let's see if it runs. Now let's release. Okay, so there's still this signedness mismatch issue to look into tomorrow, but having one Bugsnax left over, one known Bugsnax left over is not bad. Considering how much stuff I changed today, I'm amazed how little trouble there has been. So we'll run the LLVM tests as the last thing. And actually, let's go back and just out of curiosity, because we were for a lot of time dumping main here and not this. This has been a good function to dump, but I'm not as familiar with it. I want to go back and see if we got any gains on main. I'm not sure that we did because it like didn't have some of these constructs that we were using, but I'm curious. 308, we eliminated one instruction. We are now down to 308. We started at 556. We went to 545. Now we've made it all the way to 308. And maybe next stop is 300 blackout. Is Sokoban performing better now? Yes, it is. Significantly so, like it is definitely noticeable. So we did this a minute ago, but we'll do it again to celebrate. It also compiles a little faster, interestingly. So here, you know, this was a few days ago, this was 14. Then we kind of got it up to 15, 16. Now it's like high 17, low 18 FPS. 18 FPS is really a lot more than 14 FPS. So that's great. And that's just the build that we make in 0.65 seconds that, you know, no optimization whatsoever. I am very happy with today and in general the work that I've been doing on the compiler lately. It has been very fulfilling and wonderful, honestly. And this is my gains to-do list. You see, there are some items that are crossed out. There are some items that are not crossed out. This means we will be able to get more gains. This means we will drive that Weissman score down. I don't know how much further down, but significantly. I feel like if we do these things on this list, there might be an equal number or more amount of gains as what we got today. So we got about 15,000 gains today in this stream. We got other gains this morning, but we got about 15,000 in this stream. So there might be another 15,000 on this piece of paper, which would bring us to 365, which would be amazing. All right, so we'll pick this up probably tomorrow sometime. I don't know if it'll be in the morning or in the afternoon. But yeah. Thanks, everybody, for coming by. We will do more gains. I'm not going to raid anyone because it's hard to do that late at night. Have a good time. Have a good programming time. Have a good game playing time. Whatever works for you. See ya.